Welcome to Janet's Planet, where we are traveling at the speed of thought. Today we're going to take a look at what it takes to send a rover to Mars. But first, let's find out how much you know about Mars. There are 8 planets in our solar system. How many planets away from the sun is Mars? Is it A, the first planet from the sun, B, the 6th planet from the sun, or C, the 4th planet from the sun? If you said C, the 4th planet from the sun, you are correct. Mars is located between Earth and Jupiter. Now, Earth has 1 moon, but some planets have no moons at all, and others have dozens of moons. How many moons do you think Mars has? Oh, if you guessed 2 moons, you're correct. The 2 Martian moons are Phobos and Deimos. Now, do you think Mars is bigger or smaller than Earth? What about our moon? Is Mars bigger or smaller than the moon? Well, Mars is about half the diameter of the Earth, which is about twice the diameter of the moon. Mars has about 1/10 the mass of Earth, and because it has less mass, that means that it has less gravity, about 62.5% less than you're used to here on Earth. In fact, if you weighed 100 pounds on Earth, you'd only weigh 38 pounds on Mars. And that means that Mars has about 38% Earth's gravity. Now, Mars is about 142 million miles from the sun. Being further from the sun means that its orbit is a longer path, or takes a while longer to make that full revolution around the sun. So a year, or the time it takes to make 1 trip around the sun for Mars, is 687 days. And its day is longer than an Earth day. A solar day on Mars is 24 hours, 39 minutes, and 35 seconds. What would you do with all that extra time? What would living on Mars actually be like? I mean, who's going to make up the first ever Martian clock? I mean, how easy would it really be to survive? The atmosphere on Mars is 96% carbon dioxide and extremely thin. No real oxygen for us to breathe. There's no liquid water on the surface to drink either. The landscape is freezing with no protection from the sun's radiation or from passing dust storms. Now, the keys to survival will be technology, research, and testing. But you would see some things that remind you of Earth because Mars has volcanoes, flat plains, mountains. Scientists can also see channels that look like they were carved by rivers and streams a very long time ago. These are areas we want to explore for signs that life once may have survived there. So, how exactly do you get to Mars? Well, if you want to send a spacecraft all the way to Mars, first you'll need a fast rocket to escape the pull of Earth's gravity. The heavier your spacecraft, the more powerful your rocket needs to be to lift off. Next, make sure you launch at the right time. Mars and Earth orbit the sun at different speeds and distances. I mean, sometimes they're really far apart, and other times they're a bit closer together. About every 2 years, the 2 planets are in perfect positions to get to Mars with the least amount of rocket fuel. And that's important. A total trip is over 300 million miles. I mean, finally, make sure your aim is right. You can't shoot for where Mars is at launch time. You have to aim for where it will be when you get there. It's a lot like how a quarterback passes a football. Also, you may need a few thrusts to correct your direction along the way so you don't miss Mars. If all goes well, you'll get to the red planet in about 7 or 8 months. And then if you actually want to land on Mars, well, that's a whole other challenge. Over the years, we've sent 4 rovers to the Red Planet: Sojourner, Spirit and Opportunity, and Curiosity. The Perseverance rover, which is part of the Mars 2020 mission, will make number 5. It was launched last summer and is set to arrive on February 18, 2021. But I've got a question. Why were all of the people working on Perseverance rover wearing clean suits and masks? To find out that answer, let's talk to a scientist who can help explain why it's so important to keep anything we send to space, another planet, or celestial body super clean.
It's really important that we send a rover that's clean and we make sure that it doesn't contaminate Mars. My name is Mujige Stricker and I protect Mars from Earth bacteria. The next Mars rover is slated to go to Mars, collect samples so that eventually we can bring those samples back to Earth and determine for the very first time, did life exist on Mars? There's nothing that we can build that's sterile. So we take swabs and wipes of the spacecraft as it's being built. It gets put in an oven, it gets put in various chambers and clean rooms so that we can maintain that level of cleanliness. If we do find something on Mars, we have to make sure it's something that actually came from Mars and not something that hitched a ride. This is the place where the magic happens. Oh, it's definitely cool. In this lab, we look specifically at spores. So spores are those hardy microorganisms that can actually survive if it made it on the spacecraft in the journey through space, through the vacuum. It's very humbling to be a part of this big project because there are hundreds of people that have to come together and build a spacecraft. There's no one person that can say, I did this, I made this happen. It's always a we. I owe it all to Carl Sagan and watching the cosmos. I remember being a little kid, going to the public library and renting that VHS. And from that moment, the light bulb turned on. It actually was the start of my passion of science communication. We are citizens of our universe. We have to be good ambassadors when we are exploring other planets, other moons. So it's the right thing to do.
Now that everything is clean and ready to go, how exactly do you land on Mars? Very carefully. Your spacecraft hurtles toward the planet at thousands of miles per hour, so you'll have to hit the brakes in a hurry. And first, your capsule needs a heat shield, which protects the spacecraft inside from the heat and friction of entry into the atmosphere. Now, friction will slow you down about 90%. Then you're going to have to use a parachute to slow you down even more. And still, you're going to be falling at over 100 miles per hour, so you're going to need the right system to land safely. Here are some options. With a small to mid-sized rover, you use a cushion of airbags along with some retro rockets. Your impact will be about 30 miles an hour. You'll bounce to a stop. Now with a large lander, you could use retro rockets and landing legs to touch down going about 6 miles an hour. Or with a large heavy rover, use a big jet pack to slow down to under 2 miles an hour, then gently lower it on cables to land on its wheels. Any way you do it, you're going to need skill and some hard work. There's nothing easy about landing on Mars. Spacecraft like NASA's Perseverance Mars rover will be traveling really fast through space towards a target landing spot, and because the rover will be landing by itself with no real-time help from people on Earth, scientists and engineers must do a lot of work in advance, understanding the forces and motions involved, then programming the computer to make sure the rover lands at the right spot. NASA's Artemis program will launch astronauts from Earth to a moon orbiting gateway station. From this gateway, astronauts will fly on a lunar lander to land and explore on the moon. As you can see, it's necessary to understand the motion of all the objects involved, the spacecraft, the lander, and the planet. Now let's set up a challenge for you to try at home. You're going to need a few materials, about 9 feet of string or anything string-like, so you can use fishing line or dental floss, whatever you have, a disposable cup, a paper clip, some tape, scissors, a marble, or another object that will serve as your lander. You're going to also need a target of some sort. You can print out our template or make a target of your own. Just set up a zip line by tying the ends of the string to 2 chairs or use a door handle in a chair. One end of the string should be higher than the other. The more slanted your zip line, the faster your spacecraft will travel. You're going to place the target on the floor under the zip line about 2 feet from the low end. Use the paper clip to hang your spacecraft cup from the zip line. Now make sure the cup and their paper clip can slide freely from the top of the zip line down to the bottom. Now it's time to design and build your spacecraft. Figure out how to modify the paper cup to carry the marble down the zip line to land on the target using the materials you have on hand. Will the marble travel inside the cup, outside of the cup, on a platform underneath it? How will your spacecraft release the marble lander while zipping down the line? Consider whether you will use an automatic release system or a remotely activated release system. If you'd like, you can use additional string tied to your cup to create a remotely activated release system. Now, let's test your design. Release your cup at the top of the zip line and try to land your marble on the target while your spacecraft is moving. Use the numbered rings on your target to keep track of your accuracy. Repeat your run several times to get consistent results. Now, think of how you might improve your design. Make a modification and try the experiment again. Keep making modifications and testing your design after each one to see how accurate you can get. Can you consistently get to bullseye? Getting close to the center of the target is what NASA engineers must do when they land a spacecraft on another planet or on the moon. Here are a few video submissions we received from good crewmates of Janet's Planet trying out their on-target experiments.
I added tape to the paper clip.
Way to go, my awesome engineers. To check out this activity online, go to the Mars 2020 STEM Toolkit. How do you choose a landing site? You want to study Mars with a lander or a rover, but where exactly do you send it? It's a tricky question for engineers and scientists. You want it all, to land, work, and discover. To land safely means no high elevation sites where there isn't enough atmosphere to slow you down in time. Try to avoid places with steep slopes or big rocks that could damage something. You also don't want to sink into a thick layer of dust. Working is easier near the equator where seasons aren't so extreme and where solar panels can get lots of sun. Of course, don't send a rover somewhere it can't drive. And most importantly is, what do you want to discover? Some sites are great for studying rock layers. Others might be perfect to listen for Mars quakes. Using Mars orbiters, you can collect lots of data on potential sites. But when you find the best spot to land, work, and discover, you have found your new home on Mars. Perseverance will land in a region of Mars called Jezero Crater. This crater is interesting to scientists because it may have once been the site of an ancient river delta. The rocks in this region could tell us about the history of the red planet. Scientists believe it might be possible that life existed a long time ago on Mars. If that were the case, there would probably be teeny tiny little organisms, something like bacteria, here on Earth. Did life ever really get started on Mars? That's the big question. The Mars 2020 mission hopes to answer that question. The mission will send a rover very similar to Curiosity to explore the rocks, dirt, and air on Mars. And like Curiosity, the Perseverance rover is the size of a small SUV. The new rover has different goals and different science instruments. It will look directly for signs of past life on Mars. We'll even collect samples that can one day be returned to Earth for us to study. The Martian atmosphere is mostly carbon dioxide, which humans cannot breathe. Perseverance will test a method for separating oxygen from the carbon dioxide in the Martian atmosphere using an instrument called MOXIE. This will help NASA develop the best designs for devices that might provide oxygen for breathing and even for launching rockets to return from Mars one day. So let's meet one of our engineers that builds the rovers that go to Mars.
I'm Aaron Yazzie. I grew up in Holbrook, Arizona, a small town near the Navajo Nation. As a kid, I played outside in the Rocky Desert using my imagination to invent and build things. I graduated from Stanford University with a degree in mechanical engineering. I now work at the NASA Jet Propulsion Laboratory, where I help design and build Mars rovers and landers that play in the desert, just like I used to. For all you students out there with a big imagination, you're already on your way to becoming a great engineer.
Once you land the rover on Mars, how do rovers drive on Mars? First of all, there's no joystick for driving a Mars rover. Before a rover hits the road, engineers send computer commands overnight telling it where to go the next day. Depending on how tricky the terrain is, rover drivers have two options. They can send a string of specific commands like drive forward 5 meters, then turn right 90 degrees. The rover turns its wheels enough times to add up to 5 meters and then turns in place. Or if it looks safe, they can let the rover think on its own. They write commands like, "See that rock over there? Find your way there safely." Then, using 2 cameras like human eyes, the rover gets a 3D view of hazards such as large rocks and steep slopes. After mapping the danger zones, it plots the safest route to avoid them. Either way, did the rover complete its drive as planned? Engineers double-check when the rover sends back a postcard of its new spot on Mars. Did you know NASA's Send Your Name to Mars campaign invited people from around the world to submit their names to ride aboard NASA's next rover to the Red Planet? In fact, some 10,932,295 people did just that. These names were then stenciled by electron beam onto 3 fingernail-sized silicon chips, along with the essays of the 155 finalists in NASA's Name the Rover contest. Alex Mather was the winner of that NASA essay contest.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We are always curious and seek opportunity. We have the spirit and insight to explore the Moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we miss the most important thing: perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation, but as humans, will not give up. The human race will always persevere into the future. My name is Alexander Mather, and that's why I chose Perseverance as the name of NASA's next Mars rover. I don't really think that there is a word in any human language that can describe the feeling of having your name selected to be part of a mission from the greatest agency in the world, doing the most important things to help humanity spread to the stars. I am 13 years old, and I did not expect that I would be making any form of impact on human space exploration like this until I was at least out of college, or maybe in an internship. And here I am, and I just named a rover. Something I submitted was chosen by people who one day I plan to work with, and that's incredible.
Vanessa Rupani's essay inspired the naming of the Mars helicopter.
Ingenuity represents the most remarkable things that humanity is capable of. These achievements are not just the product of pure determination, they're a combination of human perseverance and ingenuity.
Hi, Vanessa. My name is Mimi Ong. I work at NASA Jet Propulsion Laboratory, JPL, and my job there is project manager for Mars Helicopter. Mars Helicopter is a technology demonstration flight experiment that Mars 2020 Perseverance rover is hosting. And we're going for the attempt at flying the first ever flight on another planet. So I've been really excited about this phone call to talk to you because I'm getting to share with you the news that your proposed name has been chosen as the name for Mars Helicopter.
Wow, that's amazing.
So on behalf of our entire Mars Helicopter team, I'd like to thank you for our name for our Mars Helicopter, Ingenuity. It's the perfect name for us. We love the name, so thank you.
Thank you, guys. Ingenuity is what allows people to accomplish amazing things, and it allows us to expand our horizons to the edges of the universe.
During the Mission to Mars Student Challenge, I challenged my own virtual Astronaut Academy kids to create and make their very own cardboard rover. And they had one 6-inch piece of cardboard and then two 2.5-inch pieces of cardboard for the front wheels. You're going to need a sharpened pencil that will act as your axle. You're also going to have to figure out how to use rubber bands to make those wheels spin. If you have it, a straw and some candy with some holes in it, some tape, scissors, and a ruler if you got it. But if you go, I don't have all of this stuff, what kind of cardboard rover can you create? If you happen to go by the instructions on the JPL website, it will talk you through each and every step, from folding that 6-by-6-inch piece of cardboard into threes. Now this is again where if you've got a good, a good ruler, you can do that, or you can just eyeball it. So basically you want to fold that into 3 parts. So you have the one thing, it's like 1, 2, and 3. So you've got 3 parts. Isn't that interesting? All of a sudden, that looks like a nice little trough. This is where your front pencil is going to go. So you want to make sure that this side and this side match up. You don't want it to be uneven. So that's one little hint I'll give you. Then these make your tires. I know, you would think NASA has heard of round wheels before, but again, the Rover tires are made specifically for going over interesting terrain, so maybe the squares give us a bit more traction. See what you create. Now, with a couple of rubber bands, you will, and you may want to use just one big one. It calls for using 2. You'll have to see how strong your rubber bands are. But then you're going to just loop it and make a little slip knot. Ooh, did you see what I did there? Now a candy with a hole in it can come in very handy. All you have to do is slip your straw through that hole. Now, you may have to bend that straw and tape that down so that your back wheel operates correctly. So you just want to do that. Now again, I'm going pretty fast here, but what you would want to do is make sure none of the tape impedes with how your wheel rolls there in the back. This is going to carry and go under the underside of your rover body and go like this. So again, get creative. Now check out and see the rovers my students made.
Hi, my name is Carter. I'm 9 years old, and here's my cardboard Mars rover.
Okay.
You ready?
Yep.
There's my rover.
This is the rover I made out of cardboard, and when I pull this rod, it will go forward. 8, 7, 6, 5, 4, 3, 2, 1.
Deploy!
Yay! Just a die.
Hey, go!
Nice! Yes!
So, get to creating. Make your own cardboard rover. I just did. All right, not bad. Maybe a little redesign, but hey, wind it up and see how far your rover will go. Perseverance rover will land on Mars near Jezero crater, but in the meantime, you can get your own rover view. Just print out, cut out, decorate, and add some 3D glasses. Make your rover view today. And when you do, we want to see your rover view. For resources for the countdown to Mars, go to NASA Next Gen STEM. This is your mission to Mars. Use your art to draw, design, and execute your mission. On February 18th, we will all join together and watch Perseverance successfully land on the red planet. This mission is yours. This challenge is yours if you accept it. It's the NASA Mission to Mars Student Challenge. Let your mind revolve around this thought. Perseverance and ingenuity are great character traits and true examples of pioneering science at its best. And that's the view from Janet's planet.